In the beginning, there was only silence, a primordial quiet that stretched across eons before life dared to crawl from the cosmic womb. But within that silence, something stirred, something that would birth creatures so alien, so impossibly twisted by evolution's cruel hand, that their very existence challenges our understanding of what life can become. Beneath your feet, at this very moment, lies the largest graveyard on Earth. Not a cemetery of human bones, but a vast necropolis, stretching through geological time, a fossil record that reads like the discarded manuscripts of a cosmic horror writer. Every step you take crosses the compressed remains of creatures that once breathed, hunted, and died in worlds so alien they might as well be from distant planets. The rocks beneath our feet whisper secrets that chill the blood they speak of, biological experiments that nature tried and abandoned, evolutionary rough drafts that were crumpled up and tossed into the geological wastebasket. But unlike discarded papers, these failed experiments became immortalized in stone, their twisted forms preserved as eternal monuments to evolution's willingness to try anything, no matter how nightmarish the result. Modern paleontologists work like forensic investigators at crime scenes that are millions of years old. They piece together fragments of bone and shell, never knowing what abomination they might resurrect from stone. Each discovery adds another piece to a jigsaw puzzle that, when completed, reveals not the familiar world we know, but something far more disturbing, a planet that once hosted forms of life so bizarre they seem crafted by the fevered imagination of a mad god. In the climate-controlled storage rooms of natural history museums around the world, millions of fossils wait in darkness. Each specimen is a messenger from deep time, carrying news of biological possibilities that were explored and then extinguished. They are the physical evidence of evolution's ruthless experimentation, proof that for every successful design we see in nature today, countless others were tested and found wanting. But these are not merely old bones and shells. Preserved within their mineral matrices are the ghost stories of ancient cells, the phantom architecture of proteins that once animated forms of life so alien that modern taxonomy struggles to classify them. Some fossils contain molecular signatures of biochemistries that no longer exist on Earth, biological languages that were spoken for millions of years and then fell silent forever. The fossil record is not a library of life's greatest hits. It is a catalogue of biological horror stories, chronicles of creatures that pushed the boundaries of what vertebrate and invertebrate anatomy could become. These ancient organisms didn't just look different from modern life. They functioned according to biological rules that seem to have been written in a universe with different physical laws. Earth is the only known planet where evolution has conducted its grisly experiments. For over 3 billion years, natural selection has been tinkering with life like a cosmic surgeon operating without anesthesia. Most of its patients died on the operating table. Their bodies became the raw material for new experiments, their bones the foundation stones for ecosystems they would never see. Look into the compound eyes of a fossilized trilobite, and you're meeting the gaze of a creature that saw the world through biological machinery that no longer exists. Those eyes were built according to optical principles that modern animals have abandoned. They represent a different solution to the problem of vision, one that worked perfectly for over 270 million years before being discarded by evolution's relentless drive toward innovation. The deeper we dig into Earth's past, the stranger the discoveries become. In the most ancient rock layers, we find evidence of biological architectures that seem more like alien artifacts than the remains of living organisms. These fossils challenge our most basic assumptions about what life can be. They suggest that the familiar forms we see around us today represent only a tiny fraction of the biological possibilities that evolution has explored. That every fossil tells a story of failure, not the failure of individual organisms, but the failure of entire body plans, evolutionary strategies that once seemed so successful they persisted for millions of years, only to vanish without descendants. These extinct creatures are abandoned children, left behind when environmental changes rewrote the rules of survival. The fossil record is written in a language that predates human speech by hundreds of millions of years. It's a biological hieroglyphic system where bones and shells serve as characters in an alphabet of extinction. Learning to read this ancient script reveals stories that would make Edgar Allan Poe weep with envy, tales of creatures so perfectly adapted to their environments that their success became their doom when those environments changed. In the beginning there was only silence, a primordial quiet that stretched across eons before life dared to crawl from the cosmic womb. But within that silence something stirred, something that would birth creatures so alien, so impossibly twisted by evolution's cruel hand, that their very existence challenges our understanding of what life can become. Beneath your feet, at this very moment, lies the largest graveyard on Earth. Not a cemetery of human bones, but a vast necropolis, stretching through geological time, a fossil record that reads like the discarded manuscripts of a cosmic horror writer. Every step you take crosses the compressed remains of creatures that once breathed, hunted, and died in worlds so alien they might as well be from distant planets. The rocks beneath our feet whisper secrets that chill the blood they speak of, biological experiments that nature tried and abandoned, evolutionary rough drafts that were crumpled up and tossed into the geological wastebasket. But unlike discarded papers, these failed experiments became immortalized in stone, their twisted forms preserved as eternal monuments to evolution's willingness to try anything, no matter how nightmarish the result. Modern paleontologists work like forensic investigators at crime scenes that are millions of years old. They piece together fragments of bone and shell, never knowing what abomination they might resurrect from stone. Each discovery adds another piece to a jigsaw puzzle that, when completed, reveals not the familiar world we know, but something far more disturbing. A planet that once hosted forms of life so bizarre they seem crafted by the fevered imagination of a mad god. In the climate-controlled storage rooms of natural history museums around the world, millions of fossils wait in darkness. Each specimen is a messenger from deep time, carrying news of biological possibilities that were explored and then extinguished. They are the physical evidence of evolution's ruthless experimentation, proof that for every successful design we see in nature today, countless others were tested and found wanting. But these are not merely old bones and shells. Preserved within their mineral matrices are the ghost stories of ancient cells, the phantom architecture of proteins that once animated forms of life so alien that modern taxonomy struggles to classify them. Some fossils contain molecular signatures of biochemistries that no longer exist on Earth, biological languages that were spoken for millions of years and then fell silent forever. The fossil record is not a library of life's greatest hits. It is a catalogue of biological horror stories, chronicles of creatures that pushed the boundaries of what vertebrate and invertebrate anatomy could become. These ancient organisms didn't just look different from modern life. They functioned according to biological rules that seem to have been written in a universe with different physical laws. Earth is the only known planet where evolution has conducted its grisly experiments. For over 3 billion years, natural selection has been tinkering with life like a cosmic surgeon operating without anesthesia. Most of its patients died on the operating table. Their bodies became the raw material for new experiments. Their bones the foundation stones for ecosystems they would never see. Look into the compound eyes of a fossilized trilobite, and you're meeting the gaze of a creature that saw the world through biological machinery that no longer exists. Those eyes were built according to optical principles that modern animals have abandoned. They represent a different solution to the problem of vision, one that worked perfectly for over 270 million years before being discarded by evolution's relentless drive toward innovation. The deeper we dig into Earth's past, the stranger the discoveries become. In the most ancient rock layers, we find evidence of biological architectures that seem more like alien artifacts than the remains of living organisms. These fossils challenge our most basic assumptions about what life can be. They suggest that the familiar forms we see around us today represent only a tiny fraction of the biological possibilities that evolution has explored. Every fossil tells a story of failure. Not the failure of individual organisms, but the failure of entire body plans, evolutionary strategies that once seemed so successful they persisted for millions of years, only to vanish without descendants. These extinct creatures are abandoned children, left behind when environmental changes rewrote the rules of survival. That the fossil record is written in a language that predates human speech by hundreds of millions of years. It's a biological hieroglyphic system where bones and shells serve as characters in an alphabet of extinction. Learning to read this ancient script reveals stories that would make Edgar Allan Poe weep with envy, tales of creatures so perfectly adapted to their environments that their success became their doom when those environments changed. Modern technology allows us to see inside fossils without destroying them, revealing internal anatomies that blur the line between biology and engineering. Some of these ancient creatures possessed mechanical structures, bone arrangements, and muscle systems that seem to have been designed by entities with a fundamentally different understanding of how living things should work. In laboratories around the world, paleontologists use acids to dissolve away the rock matrix that has entombed these creatures for millions of years. It's a process that resembles resurrection more than science, the gradual revelation of forms that were buried when the continents were in different positions, when the atmosphere had a different composition, when the very rules of ecology were written in an alien tongue. Each fossil quarry is a portal to a vanished world, a window into biological realities that no human eye has ever witnessed in life. The creatures that emerged from these stone tombs lived and died in ecosystems that followed ecological rules we can barely comprehend. They were part of food webs so alien that modern biology has no framework for understanding how they functioned. Even the simplest fossils tell disturbing stories. Ancient bacteria preserved in billion-year-old rocks show us that life has always been willing to experiment with biochemistries that modern organisms cannot tolerate. These microscopic fossils are evidence that Earth has repeatedly served as a testing ground for biological innovations that push the boundaries of what chemistry can accomplish in living systems. Museum dioramas attempt to bring ancient ecosystems back to life, but they can only hint at the true alienness of these vanished worlds. The artists who create these scenes are forced to make educated guesses about how these creatures lived, how they moved, how they interacted with their environments. Often, the reality preserved in the fossil record is far stranger than any artistic interpretation can capture. Paleontologists' field notes read like inventory lists from an alien autopsy. Structures that have no modern analogues must be described in terms that sound more like engineering specifications than biological observations. These scientists have become translators between the language of ancient life and the vocabulary of modern biology, a task that often proves impossible because the concepts simply don't exist in contemporary science. The moment of discovery is both triumph and tragedy. Each fossil that emerges from its rocky tomb is a resurrection and a funeral simultaneously. These creatures live again in our imagination, but they also die again as we confront the reality that they and their entire worlds are gone forever. We are archaeologists of extinction, museum curators for biological possibilities that will never return. The reconstruction of ancient life is an act of scientific necromancy. We piece together fragments of bone and shell, trying to resurrect creatures that have been dead for longer than our species has existed. But unlike Frankenstein's monster, these reconstructed beings reveal themselves to be far more alien than any work of fiction. They are nature's own science experiments, proof that evolution is willing to try biological solutions that seem to violate the rules of sensible design. We stand at the threshold of the greatest horror story ever told, not a tale of supernatural monsters, but the true history of life on Earth. It is a story populated by creatures so bizarre that they make the inventions of horror writers seem mundane by comparison. These are not the fantasies of human imagination, but the documented reality of biological experimentation conducted on a planetary scale across geological time. The Earth beneath your feet is a vast museum of biological horror, where every stone potentially contains the remains of creatures that push the boundaries of what life can become. Their stories are written in calcium phosphate and silica, preserved in languages that predate human speech by hundreds of millions of years. Tonight, as you sleep, you rest above the greatest graveyard in the known universe, a necropolis where evolution's strangest children wait in stone silence, their fossilized forms whispering secrets that will haunt your dreams and challenge everything you thought you knew about the possibilities of life. The Burgess Shale's carnival of flesh deep within the Canadian Rockies lies a tomb more terrifying than any Egyptian pyramid. The Burgess Shale, where 508 million years ago, the Cambrian seas became a laboratory for biological horrors that defy comprehension. This ancient underwater graveyard preserves creatures so alien in their construction that they seem like the fevered nightmares of some cosmic entity experimenting with the very concept of life itself. Here lies Hallucigenia, a creature whose very name captures the surreal terror of its existence. When paleontologists first discovered these fossils embedded in the dark shale, they thought they were looking at the fossilized remains of an ancient hallucination. The creature seemed to have been assembled from spare parts left over from evolution's most twisted experiments, a biological impossibility that challenged every assumption about how animals should be constructed. Picture, if you dare, a creature that walked through ancient seas on 7 pairs of stilts, each one tipped with a sharp claw designed for gripping the muddy seafloor. Its back was armored with 2 rows of defensive spines, each one needle-sharp and positioned to impale any predator foolish enough to attack from above. But this defensive arrangement was only the beginning of Hallucigenia's anatomical madness, a preview of horrors yet to be revealed. At what researchers initially thought was its tail, but later discovered was actually its head, Hallucigenia, who possessed a feeding apparatus that looks like something extracted from a surgical nightmare. Rows of needle-sharp teeth surrounded a proboscis that could extend and retract like a biological drill bit, allowing the creature to probe the seafloor for buried prey with mechanical precision. The mouth itself was a circular arrangement of cutting surfaces that could grip and process food with efficiency that modern predators can barely match. For decades, paleontologists couldn't agree on which end was the head and which was the tail, a confusion that speaks to just how alien these creatures truly were. The creature was so anatomically bizarre that scientists literally reconstructed it upside down and backwards for years, their models showing a creature walking on spines with its feeding apparatus trailing behind like some kind of biological afterthought. It was only when researchers found specimens with preserved gut contents that they realized they had been looking at evolution's idea of a cosmic joke, a creature that seemed designed specifically to confuse anyone who tried to understand it. The fact that professional paleontologists, experts who have spent their entire careers studying ancient life, could misinterpret these fossils so completely tells us something deeply disturbing about Cambrian evolution. These creatures didn't just look different from modern animals. They were organized according to biological principles that modern life has completely abandoned, following architectural rules that seem to have been written by entities with no understanding of earthly physics or anatomy. But Hallucigenia was just one performer in the Burgess Shale's carnival of flesh, a single act in a biological circus that featured creatures so bizarre they make modern animals seem boringly conventional by comparison. Each piece of split shale reveals new horrors, organisms that seem to have been designed by a committee of demons working from blueprints, drawn by mad scientists who had never seen a living thing. Meet Wewaxia, a creature that looked like medieval chainmail had been crossed with a biological pincushion and then given the ability to crawl. Its oval body was covered in overlapping scales arranged like flexible armor, while its back bristled with long, sharp spines positioned in precise rows that created a defensive barrier capable of deterring even the most determined predators. But unlike armor forged by human hands, Wewaxia's protective system was grown, not made a living fortress that moved across the Cambrian seafloor like an animated weapon. Wewaxia, fed by scraping bacterial mats off rocks with a rasping tongue, called a radula, the same basic feeding structure found in modern snails and slugs, but modified for industrial strength processing. While a garden snail uses its radula to scrape algae off your sidewalk, Wewax's version was capable of processing the tough bacterial films that coated Cambrian seafloors like biological concrete, stripping away layers of microbial growth with the efficiency of a living sandblaster. The bacterial mats that covered the Cambrian seafloor were themselves alien by modern standards, thick, rubbery carpets of microorganisms that created landscapes unlike anything found in contemporary oceans. These mats could be several inches thick and tough as leather, requiring specialized feeding equipment to process. Wewaxia was evolution's solution to this particular ecological challenge, a mobile processing unit designed to harvest energy from substrates that modern animals would find completely inedible. If Wewaxia was evolution's attempt at medieval armor, then Opabenia was its experiment in alien surveillance technology. This creature possessed 5 mushroom-shaped eyes arranged across the top of its head like biological radar dishes, giving it a 360-degree view of its underwater environment that would make modern security systems jealous. But its most disturbing feature was its proboscis, a flexible tube ending in a grasping claw that could extend. Opabenia's feeding strategy was as alien as its appearance. The creature would use its proboscis like a biological fishing line, extending the flexible tube to grab small prey before retracting it to deposit victims in its mouth. But here's where the anatomy becomes truly nightmarish. Opabenia's mouth faced backwards, positioned on the underside of its head behind the brain. The creature would curl its proboscis back over its head to deliver food to this rear-facing oral cavity, a feeding method that seems to violate every principle of efficient design. Watching Opabenia feed would have been like observing a biological construction crane operating in reverse, with the mouth positioned where no sensible engineer would ever place it. Yet this arrangement worked perfectly for millions of years, suggesting that evolution's definition of sensible design is far more flexible than our human preconceptions would suggest. The creature's backward mouth was not a design flaw, but an elegant solution to the specific challenges of Cambrian predation. The 5 eyes of Opabenia were not simple light-detecting organs, but sophisticated visual systems capable of processing complex information about the creature's environment. Each eye could move independently, allowing Opabenia to track multiple objects simultaneously while using its proboscis to investigate potential prey. It was like having 5 biological security cameras mounted on a single head, each one capable of zooming and focusing on different aspects of the surrounding environment. But the true apex predator of the Burgess Shale's House of Horrors was Anomalocaris, literally the abnormal shrimp, whose name reflects paleontologists' initial confusion about what they were looking at. For years, different parts of this creature were classified as entirely separate animals, a misidentification that speaks to just how impossible the complete organism seemed to early researchers. The massive grasping arms were thought to be large, shrimp-like crustaceans. The circular mouth was classified as a peculiar jellyfish. The body segments were mistaken for some kind of sea cucumber. Only when complete specimens were finally discovered did paleontologists realize they were looking at pieces of a single nightmare, a predator over 6 feet long that cruised Cambrian seas like a biological attack helicopter, combining size, speed, and predatory sophistication in ways that wouldn't be seen again until the evolution of large vertebrate predators hundreds of millions of years later. Anomalocaris was the undisputed ruler of its ecosystem, a position it maintained through evolutionary innovations that seemed borrowed from science fiction. The creature swam by undulating its body like a massive stingray, propelling itself through ancient waters with undulations that created waves of muscle contraction running from head to tail. But this graceful swimming motion became terrifying when Anomalocaris encountered potential prey. Its massive grasping arms could flex and bend with dozens of individual joints, allowing them to curl around victims like organic tentacles, equipped with rows of sharp spines for maintaining grip. Each grasping arm was over 3 feet long and lined with flexible spines that could dig into prey and hold it securely while being transported to the creature's mouth. These weren't simple grabbing appendages but sophisticated manipulative organs capable of fine motor control that allowed Anomalocaris to handle prey with surgical precision. That creature could pluck small organisms from the seafloor or grapple with larger victims, adjusting its grip strength and positioning based on the size and struggle intensity of its prey. The mouth of Anomalocaris was perhaps the most terrifying, a feature of an already nightmarish creature. A circular arrangement of teeth organized in concentric rings like the iris of a camera lens. Dozens of triangular razor-sharp dental elements could contract inward to grip and process prey, with the entire structure capable of adjusting its aperture size depending on what was being consumed. It was a living garbage disposal that could fine-tune its processing capacity based on the meal at hand. We know how Anomalocaris fed because its victims preserved evidence of the attacks in excruciating detail. Trilobite fossils from the Burgess Shale show characteristic bite marks, circular patterns of damage that match the predator's mouth geometry with courtroom precision. But these weren't random feeding frenzies. The bite patterns show evidence of surgical precision that suggests Anomalocaris was a selective predator, capable of choosing exactly which parts of its victims to consume. Biomechanical studies suggest that Anomalocaris couldn't actually bite through the hard shells of large trilobites, despite its impressive dental arrangement. Instead, the creature appears to have been a suction feeder, using its circular mouth to create powerful vacuum forces that could pull soft tissues out through gaps and joints in its victim's armor. It was performing biological surgery 500 million years before the first medical scalpel was invented, extracting nutritious organs while leaving empty shells behind. The precision of these feeding attacks is what makes them truly disturbing from a modern perspective. Anomalocaris wasn't a mindless eating machine, but an intelligent predator capable of sophisticated behavioral strategies. Some trilobite fossils show evidence of multiple attack attempts, suggesting that prey could sometimes escape initial encounters, only to be tracked down and finished off in subsequent hunts. This implies not just intelligence but memory, the ability to remember specific prey individuals and continue hunting them over extended periods. The Burgess Shale preserves not just individual creatures but entire ecosystems frozen in geological, amber, biological crime scenes where predators and prey are preserved together in their final moments. Their death struggles immortalized in stone for us to study and fear. On single slabs of shale, we can see the complete cast of characters from Cambrian ecological dramas playing out their ancient roles in an alien underwater theater. Anomalocaris arms reach toward trilobite shells and fossils that capture predator-prey interactions with documentary precision. Hallucinogenious specimens are found clustered together as if they had been seeking safety in numbers when catastrophe struck. Wiwaxia individuals are positioned near bacterial mat formations, caught in the act of feeding when whatever disaster created the Burgess Shale preservation descended upon their world like a geological apocalypse. The Cambrian seas themselves were unlike any ocean that exists today, filled with water that was different in fundamental ways from anything modern marine life has ever experienced. The ancient oceans were lower in oxygen but higher in dissolved minerals, giving them an almost viscous quality that would feel alien to any modern swimmer. The chemistry was different, the temperature gradients were different, even the way light penetrated the water was different due to atmospheric conditions that no longer exist on Earth. The seafloor was carpeted with bacterial mats that created biological landscapes, completely unlike anything found in contemporary oceans. These microbial carpets were thick, rubbery structures that could support the weight of crawling organisms while providing a completely different ecological foundation than the sandy or muddy bottoms of modern seas. It was an alien world populated by alien creatures following alien rules of survival, where even the most basic environmental conditions were foreign by today's standards. What makes the Burgess Shale truly terrifying from a paleontological perspective is the extraordinary quality of preservation that allows us to see these creatures in intimate detail. These aren't just shells and hard parts scattered randomly through rock layers. Entire soft-bodied organisms are preserved with their muscles, digestive systems, and even nervous tissues intact. It's as if these creatures were at the moment of death, their alien anatomies preserved in mineral form for us to study and attempt to understand. The preservation process itself adds to the horror of these discoveries. The creatures were buried so rapidly and completely that they had no time to decay before fossilization began. This suggests a catastrophic burial event, perhaps an underwater avalanche or sudden chemical change in the ocean that killed entire communities simultaneously. The Burgess Shale represents a mass death event that preserved an alien ecosystem at the moment of its destruction. Among the Burgess Shale's collection of monsters lurks a small, seemingly insignificant creature called Pikaia that represents something even more disturbing than the armored nightmare surrounding it. Unlike the bizarre experimental forms that dominated Cambrian seas, Pikaia possessed something that would eventually inherit the Earth, a primitive backbone structure that marks it as one of the earliest known members of our own evolutionary lineage. This tiny worm-like creature with its simple nerve cord and basic segmentation represents one of our most ancient ancestors, a reminder that we humans are products of the same Cambrian explosion that created the monsters preserved around it. If Pikaia had not survived the ecological lottery of ancient seas, there would be no vertebrates today, no fish, no dinosaurs, no mammals, no humans. Our entire evolutionary lineage hung by a thread in those ancient waters, represented by a creature so small and fragile that it's miraculous any fossils of it exist at all. The discovery of Pikaia among the Burgess Shale fauna forces us to confront an uncomfortable truth about our own origins. We are not the inevitable result of evolutionary progress, but the descendants of one lucky survivor from a world populated by creatures that were, in many ways, far more interesting and innovative than anything that came after. The Cambrian explosion was evolution's most creative period, when life experimented with biological possibilities that were never tried again. The Burgess Shale was first discovered in 1909 by Charles Doolittle Walcott, a paleontologist who realized he had stumbled upon something extraordinary but couldn't have imagined the true significance of his find. Working alone in the harsh conditions of the Canadian Rockies, Walcott carefully extracted fossil after fossil, each one more bizarre than the last. But even with his considerable expertise and Victorian sensibilities, he couldn't fully appreciate what he was looking at: evolution's most experimental phase, when life tried biological solutions that seem almost supernatural in their strangeness. Modern techniques continue to reveal new horrors hidden within these ancient rocks, each technological advance bringing these creatures back to life in ways that make them seem more alien rather than more familiar. Electron microscopy reveals cellular structures preserved in impossible detail, showing us organelles and membrane systems from creatures that have been dead for over 500 million years. Chemical analysis detects traces of original organic molecules, giving us glimpses into biochemistries that no longer exist anywhere on Earth. Computer reconstructions attempt to show us what the complete Burgess Shale ecosystem looked like during life, but even the most sophisticated animations can only hint at the true alienness of this underwater world. Imagine diving in these ancient seas, your mask fogging as your brain tries to process what you're seeing, your mind struggling to categorize creatures that seem to follow no earthly rules of anatomy, behavior, or ecological interaction even. The more familiar-looking creatures of the Burgess Shale possessed features that remind us how fundamentally different ancient life could be from anything we know today. Trilobite eyes, for example, were built like precision optical instruments, with individual lenses made of calcite crystal that could focus light with mathematical precision. These weren't just organs of vision, but biological telescopes capable of detecting prey and predators across vast distances in the murky waters of Cambrian seas. Trilobite vision was so sophisticated that it wouldn't be equaled in complexity until the evolution of vertebrate camera eyes hundreds of millions of years later. They could see ultraviolet light, detect polarization patterns invisible to human eyes, and process multiple overlapping images simultaneously to create three-dimensional maps of their environment. They were living surveillance systems, monitoring their underwater world with capabilities that modern security technology can barely duplicate. Today, the Burgess Shale sits high in the Canadian Rockies, accessible only to researchers willing to endure harsh weather conditions, treacherous hiking, and the psychological isolation of one of the most remote fossil localities on Earth. It's somehow fitting that these creatures should be entombed in such an alien landscape, fossilized aliens preserved in a location that feels as foreign and hostile as the ancient seas they once inhabited. Working the Burgess Shale by headlamp in the thin mountain air, with vast wilderness stretching in all directions and storm clouds gathering on distant peaks, researchers report an almost supernatural sense of connection to deep time. They are literally touching creatures that lived when the continents were arranged in completely different configurations, when the atmosphere had a radically different composition, when the very principles of ecology were being established for the first time in Earth's history. Each fossil that emerges from the Burgess Shale is simultaneously a scientific treasure and a philosophical nightmare, forcing us to confront the reality that evolution is not a progressive march toward increasing complexity and familiarity, but a series of biological experiments in which most participants are doomed to failure and extinction. These creatures remind us that the forms of life we consider normal and inevitable are actually evolutionary accidents, temporary arrangements that could vanish as suddenly and completely as they first appeared. The Burgess Shale stands as a monument to evolution's most creative and terrifying period, a time when life threw biological dice with reckless abandon, creating creatures so strange they seem like the fever dreams of an alien intelligence trying to understand what Earth-based life might look like. These fossils remind us that our familiar world is built on foundations of mass extinction, populated by the evolutionary descendants of a few lucky survivors from seas that swarmed with monsters we can barely imagine. In the darkness of the Canadian Rockies, these ancient creatures wait in their stone tombs like sleeping nightmares, their fossilized forms bearing witness to biological possibilities that will never return, evolutionary experiments that were tested once and then abandoned forever. They are evolution's discarded rough drafts, preserved as eternal reminders that life's creativity knows no bounds, and that the universe of biological possibility is far larger and more terrifying than our limited human imagination can encompass. The Devonians' armored apocalypse 400 million years ago. The Devonian seas ran red with the blood of giants, their waters transformed into liquid battlefields, where evolution conducted an arms race of unprecedented savagery and innovation. This was the age of armored leviathans, when ancient oceans became hunting grounds for predators whose size, ferocity, and biomechanical sophistication turned the very act of survival into an ongoing war against living siege engines designed by natural selection's most violent imagination. In these primordial waters ruled Dunkleosteus, the undisputed apex predator of the Devonian seas, and perhaps the most terrifying fish that has ever lived, stretching 30 feet from its massive armored head to its powerful tail. This creature was evolution's answer to the question of what happens when you combine the cutting power of industrial machinery with the predatory instincts of a great white shark and the armored protection of a medieval siege engine. But Dunkleosteus was not merely large. It was a biomechanical marvel that had evolved beyond the primitive constraints of tooth-based predation, where other fish relied on rows of replaceable teeth that could break or wear down. Dunkleosteus had developed something far more sinister and efficient. Its skull bones had been modified into self-sharpening biological guillotines that grew continuously throughout the creature's life, maintaining cutting edges sharper than surgical steel. These weren't teeth in any recognizable sense, but razor-sharp bone plates that functioned like the blades of an organic meat slicer. Every time Dunkleosteus bit down on prey, these cutting surfaces honed themselves against each other with mechanical precision, creating and maintaining edges so sharp they could slice through bone, cartilage, and armor with equal ease. The creature's jaw was essentially a biological sawmill, powered by muscle systems that could generate bite forces exceeding 11,000 pounds per square inch. To put this crushing power into perspective, a modern great white shark, one of our planet's most formidable predators, can generate a bite force of approximately 4,000 pounds per square inch. Dunkleosteus could bite down with nearly 3 times that pressure, delivering cutting forces sufficient to shear through steel plates of moderate thickness. This was not merely a predator but a living hydraulic press. Equipped with precision cutting tools, the jaw muscles of Dunkleosteus were arranged in a configuration that would make a mechanical engineer weep with admiration, like the cable systems of a suspension bridge. These muscular arrangements concentrated enormous force precisely at the cutting edges where it could do the most damage to prey. Biomechanical studies suggest this monster could snap its jaws shut in just 50 milliseconds faster than a human eye can track movement, faster than most prey animals could react to the attack. This lightning-fast bite speed meant that Dunk was not just powerful but explosively quick in its killing strikes. Prey animals would find themselves caught in jaws that closed with the speed of a mousetrap and the force of a hydraulic shear, their bodies surgically dismembered before their nervous systems could even register the attack. Death came not just swiftly but with industrial efficiency that turned predation into a mechanized process. The fossil record preserves evidence of Dunkleosteus feeding behavior in the form of regurgitated bone masses, fossilized vomit that tells a disturbing story about the creature's hunting success. These coprolites contain partially digested chunks of other armored fish. The chemistry of Devonian oceans themselves contributed to the apocalyptic nature of this underwater warfare. Higher carbon dioxide levels created more acidic waters that could dissolve calcium carbonate shells and bones, forcing creatures to develop new types of armor made from materials that could resist chemical attack. This led to the evolution of phosphate-based skeletal systems that were not only more durable but could be grown into more complex shapes than simple calcium structures. Some Devonian predators developed chemical weapons systems that seem borrowed from military science fiction. Certain species could secrete acids powerful enough to dissolve the protective mucus layers of prey fish, leaving them vulnerable to follow-up attacks. Others evolved neurotoxic compounds that could paralyze victims without killing them, allowing for leisurely feeding on living but helpless prey. The late Devonian extinction event that ended this reign of armored terror was one of the most devastating in Earth's history, wiping out over 75% of all marine species in what appears to have been a cascade of environmental catastrophes. Ocean acidification, temperature changes, and oxygen depletion created conditions that even the most sophisticated biological armor could not protect against. The heavily armored giants that had ruled Devonian seas for millions of years found their defensive systems useless against enemies they could not bite, cut, or intimidate. The extinction happened in stages, with different groups of armored predators disappearing at different times as environmental conditions continued to deteriorate. Dunkleosteus and its relatives were among the first to vanish, their massive size and high metabolic requirements making them vulnerable to the oxygen depletion that characterized late Devonian oceans. The filter feeders lasted longer, but even their efficient feeding systems could not extract nutrition from waters that had been stripped of most microscopic life. What makes the Devonian extinction particularly tragic from a biological perspective is that it eliminated some of the most sophisticated predator-prey systems ever to evolve in Earth's oceans. The armored giants and their equally well-defended prey had achieved a level of biological sophistication that would never be seen again. In marine ecosystems, modern oceans, for all their apparent diversity, are impoverished compared to the mechanical marvels that once ruled. Devonian seas. The disappearance of these creatures left ecological niches vacant that would not be filled again for tens of millions of years, and when they were finally occupied by new groups of organisms, the solutions were far simpler and less sophisticated than what had been lost. No modern predator approaches the biomechanical complexity of Dunkleosteus. No contemporary filter feeder matches the efficiency of Titanochus. The Devonian represented a peak of biological engineering that evolution has never again attempted to reach today. When we examine the fossilized remains of these ancient sea monsters, we are looking at the preserved components of biological weapons, systems that were more sophisticated than many human engineering projects. The cutting mechanisms, armor systems, and locomotion methods developed by Devonian creatures represent solutions to mechanical problems that our own technology is only beginning to understand and appreciate. The legacy of the Devonians' armored apocalypse can be seen in the impoverished nature of modern marine ecosystems, where the largest predators are sharks whose basic body plan hasn't changed significantly in hundreds of millions of years. These living fossils are successful precisely because they represent simple, efficient solutions that can survive mass extinctions. But they are pale shadows of the mechanized nightmares that once ruled ancient seas with weapons forged from living bone and powered by muscles that could generate forces measured in tons per square inch. When insects ruled as giants 300 million years ago, during the steamy Carboniferous period, Earth's atmosphere became a breeding ground for arthropod monstrosities that transformed familiar six-legged creatures into living nightmares of impossible size and predatory sophistication. This was a world where dragonflies cast shadows like pterodactyls, where millipedes coiled through primordial forests like armored trains, and where spiders hunted with the efficiency of pack wolves, a planet where insects had broken free from the size constraints that limit their modern descendants and grown into the dominant megafauna of terrestrial ecosystems. The architect of this arthropod apocalypse was oxygen itself, present in atmospheric concentrations that reached 35%, nearly twice the levels found in today's atmosphere. This oxygen-rich environment supercharged arthropod respiratory systems, allowing creatures that today are confined to tiny body sizes to grow into giants that would make modern insects look like insignificant specks by comparison. But these were not simply scaled-up versions of familiar creatures. They were alien monsters whose size allowed for behavioral sophistication and predatory strategies that no modern arthropod can attempt. Soaring through Carboniferous skies was Meganura, a dragonfly whose wingspan stretched over 2 feet from tip to tip, larger than many modern birds and powered by flight muscles that generated forces efficient to snap the necks of small vertebrates during high-speed aerial attacks. These were not the delicate, almost ethereal dragonflies that grace modern ponds, but aerial predators whose hunting territories covered hundreds of square miles and whose compound eyes could track prey with resolution that approached the capabilities of modern military radar systems. The compound eyes of Meganura contained over 30,000 individual visual units, each one capable of detecting movement, color changes, and polarization patterns with sensitivity that modern technology struggles to duplicate. These biological surveillance systems could simultaneously track multiple prey items while monitoring the surrounding airspace for competitors and threats, creating a three-dimensional tactical awareness that allowed these giant dragonflies to dominate Carboniferous skies with the efficiency of flying combat aircraft. But Meganura was not content to hunt the small flying insects that made up the bulk of its diet. Fossil evidence suggests these giants also attacked vertebrates, using their powerful mandibles to deliver crushing bites that could kill small amphibians and early reptiles with surgical precision. Their legs were equipped with spines arranged like organic fishhooks, allowing them to grab struggling prey and maintain their grip while delivering fatal bites to the head and neck regions. The flight mechanics of Meganura were fundamentally different from those of modern dragonflies, requiring muscle systems and wing structures that pushed arthropod aviation to its absolute limits. Each wing was a marvel of biological engineering, with internal supports arranged in geometric patterns that distributed stress loads with mathematical precision while maintaining the flexibility needed for the complex wing motions that powered their flight. These wings could beat at frequencies approaching 50 cycles per second, generating lift forces sufficient to support the creature's massive body while providing the maneuverability needed for precision attacks on fast-moving prey. The wing muscles alone accounted for over 40% of the creature's total body mass, creating flight systems that were essentially biological jet engines designed for sustained high-performance operations. But the skies were not the only domain where Carboniferous arthropods reached gigantic proportions. Crawling through the humid coal swamp forests was Arthropleura, a millipede that stretched 8 feet from head to tail and moved through ancient woodlands like a living armored train, powered by hundreds of synchronized legs. This was not a gentle herbivore, but a biological bulldozer capable of processing plant material on an industrial scale while reshaping entire forest ecosystems through its feeding activities. The exoskeleton of Arthroplura was a composite structure that would impress modern materials scientists. Overlapping plates of chitin reinforced with mineral deposits that created armor capable of deflecting attacks from the largest predators of its era. Each segment was equipped with powerful legs that could generate traction forces sufficient to push through dense vegetation and climb over obstacles that would stop smaller creatures completely. The feeding mechanism of Arthroplura was perhaps even more impressive than its size, consisting of mandibles that could process cellulose with efficiency that exceeded that of modern industrial woodchip. These giant millipedes could strip entire trees of their bark and foliage, leaving behind standing dead trunks that would eventually become the coal deposits that give the Carboniferous period its name. But Arthroplura did more than just eat vegetation. It fundamentally altered the structure and composition of Carboniferous forests through its feeding activities. Like modern elephants, these giant millipedes were ecosystem engineers whose feeding habits created clearings, maintained forest paths, and influenced the distribution and abundance of plant species. Across vast regions of the supercontinent Pangaea, the digestive system of Arthroplura was a biological fermentation chamber that could break down the toughest plant fibers using bacterial symbionts that no longer exist in modern ecosystems. This internal ecosystem could process toxins and structural compounds that would kill modern herbivores, allowing these giants to exploit food resources that were unavailable to other creatures of their era.